So these are just graphs, no application, we're just gonna graph. You'll see the top piece says that x is less than something, and then the bottom piece says that x is greater than something. That something, that number is kind of like a boundary. It divides the piecewise function into two pieces, a left piece and a right piece. So x is equal to -1 right here. So since we're focusing on lines, you're going to have some kind of thing, like a linear thing, on this side of that border, and then something over here on the right side of that border. So that's up to us to figure out what they look like.
Oh, so that makes a border that creates a border. Oh.
So our first piece is g of x equals 2x for x values less than -1.
Why is it g of x and not f of x? Is it just the same thing?
Yeah, it's the same thing, just a different name.
Oh, it's weird.
When it says x is less than -1, are we including -1 or not including -1?
Not included.
We're not including. So the first point at -1 is going to be an open circle. It might be 0. I don't think it's 0.
Wait, why is it an open circle again? I actually don't get it.
What?
Why is it open circle?
Because if it says like less than or equal to or greater than or equal to, it's including -1 because it's or equal to.
So that's like,
But if it doesn't say or equal
Oh, it's
to,
open
it's just
circle.
it has to be less than it, so it's not including it. It's just like a boundary,
Oh, so does it if it doesn't have like the greater?
the extra line. So this is going to be a closed point, open point.
Oh, does it just go back to like the graphing on a?
Yeah, it's the same concept, but it's not an inequality. Like
Yeah.
This is a piecewise function. So like we're not shading or anything here either. Alright, so this is our function. The first thing you should do is take this value, whatever it is, whatever that number is, and plug it in. That's going to give you like kind of a starting point to know what to graph first.
Alright.
So when you plug in -1, you get -2. So remember, our graph can't be -1. It has to be less than -1. So we're putting an open point at that, like where we just found that. So -1 and then -2 is right here. We're putting an open circle there. The rest of our piece, so the rest of that piece of that function is going to go over here on the left. So it might go like this, it might go like this, it might go like this, this.
Which one is the one that
Over.
like you like create like a whole bunch of lines like this and like you shade a certain area of it?
That's called an inequality, like this,
For like graphing it like that.
inequality,
Oh, so like I would actually graph that.
and then you shade.
But that's when you get 2, right? That's only one shade? Like when you get 2 of them versus
No, it could be one.
oh it could?
Yeah, you could do like one line with shading. Yeah.
Oh.
Or you could do 2 lines with shading.
Wait, what is that green line? Oh, okay, about that. Okay.
Alright, so now we need the rest of the line. How many points do you need to graph a line?
2.
So we need another point. It has to follow this domain restriction. So x is less than -1. We already plugged in -1.
0.
0 is not
No,
less
1.
than -1.
Oh wait, -2.
-2 is less.
That took me a bit. I forgot it was a negative.
You have to choose something that's less than -1. So something to the left of -1. And we get -4 when we plug in -2. You can pick whatever you want.
As long as it like corresponds.
Yeah. Now, are we including -2 when we say x is less than -1?
We.
Yeah, it's part of that. So this is just going to be like a regular point. So -2, 1, 2, 3, 4. And the rest of this is going to be a ray pointing kind of down and to the left. Because all the values less than -1 are included in this piece of the piecewise function.
So when we're like taking a quiz or test,
So then we have this other piece. We have the first piece done, we have a second piece. Second piece is 1/2 x plus 3, and we want to graph this for all values greater than or equal to -1. So that's what it says to the right of it. X is greater than or equal to -1. So this part is going to be over here. Some kind of line over here. First thing we're gonna do is plug in this point, -1, to see where we're supposed to start. Okay, so -1/2 times -1 is -1/2. -1/2 plus 3 is 2.5. So we have a point at -1, 2.5. And then it's up to you to decide if that point is either gonna be open or closed. Is it included or not included?
They include, no, not include,
How do you know if it's included?
because it's less than, no, wait, included is greater than.
We're on the second piece, so we're reading this. This
This
says
is the
x is greater than
than.
or equal to -1. We plugged in -1. Is that included in this domain?
Yeah.
Yes, it is, because it says x can be greater than -1, but it also could be equal to -1.
Oh.
So it's included. Solid point.
Closer.
So that's right here. So -1, 2.5, right there. The rest of this is gonna be somewhere over here. Maybe this way,
Bro, why'd
this
you go
way,
so
this
high
way,
up
this
for
way.
2.5? Oh.
Huh?
Never mind.
So now we need to plug in another point that is greater than -1.
Zero.
Right.
0 now.
Yeah.
Yeah.
Zero's good.
0, 0.
If you can plug in 0, always pick 0. It's just so easy. Right? Because like half of 0 is 0, and then plus 3 is 3. That one's easy to pick. 0, 3. Is this included in this domain?
No.
No.
Oh, you know what? Yes.
Yeah, it is.
Yes.
It's included.
Because it makes
So
sense.
this one's solid point.
Wait, what? Oh, cause.
If the domain is that x is greater than or equal to
It's
-1,
included.
0's over here, so it's included. So that's good. So then we're just gonna connect those 2 points. Do not go to the left, only go to the right, where x values are getting greater than -1. So don't go to the left, only go to the right. If you go to the left, you're making it not a function, which is bad. Okay, you want it to be a function, it has to pass the vertical line test.
Are you okay, Michael?
Slowly dying.
Drink some.
So I rewrote the piecewise function into 2 pieces. The left is the top, the right is the bottom.
Actually.
So on the left, we are graphing this line, which in general looks something like this. It's a negative slope, okay?
Yes.
We don't want the whole thing. We only want it for x values less than 1. This is where 1 is. We only want this part. In general, you should have a line that has a negative slope only up until 1. We're going to find exactly where it is and what kind of slope it has. So something more accurate than that. We are including 1 because it says x is less than or equal to 1. So the first point that you plug in, when you plug in 1,
1.
will be included. You should get -2.
Well,
So you
So
plugged
it's
in
1
1,
negative 2.
no, I did.
you got -2.
Yep.
It's included because right here it's including 1. So you're going to have a solid point at 1, -2.
Okay.
Then, like I said, the rest of it's going to go this way because it has a negative slope.
Yes.
We need to plug in something that's
0.
within this domain. Yeah, sure, 0. Plug in 0.
Let's go.
Which is
So
0,
that's
2.
included.
This is also
Oh,
included
yes, I
because
was
it's
right.
part of that part. So
Good
you
job.
get 1. So you get
Well, you got 1.
0, 1, which is
Oh, yeah.
God,
Here.
can't do math.
we want everything to the left of the first point we graphed because it's everything less than x is 1.
Litty.
And so it looks something like this. So it's steep because it's got a slope of -30.
I can't do math.
I know. I know, Michael. I know you can.
Questions? All right, so second piece. This is a horizontal line. Okay, it looks like this. 1, 2, 3, 4. This is where y is 4. It looks like this.
That's it?
We don't want it to go all the way across. Where do we want it to go?
Horizontal.
We want it to start at the x value 1.
Oh, so just.
Okay, you want it to start at 1. The y value is 4. Always you can't plug anything into it because it's not varying. Okay, another way of writing this function is y equals 4, always. So what that means is when x is 1, y is 4. When x is 2, y is 4. When x is 3, y is 4. I'm graphing all of these points. So it just looks like a straight, unchanging, unsloping, okay, horizontal line that goes through 4. It starts at 1 because it says x is greater than 1. It doesn't include 1 because it says x is greater than 1, and it doesn't say or equal to 1. So it just goes like that. And it still passes the vertical line test because it goes through the hole and then touches there. Questions?
That's fun.
Questions? Are you sure?
No.
The next one doesn't have inequalities. It says x is equal to something or x is not equal to something. So you're going to look at the value that it says x is either equal to or not equal to. It says 1. So this is where x equals 1, right there. So along here,
Oh, I don't have that page.
okay, along here,
Is it me or just getting colder in here?
should be getting, well, actually, maybe.
Oh.
So that's where x is equal to 1. It's not going to be something on the left and something on the right. What it's going to look like, most likely, is something like a point here and then like a line everywhere else instead. Okay, so let's see exactly what that looks like.
I don't have this page. I don't know why.
We don't know.
Your burp sucks.
Do you have it?
Yeah.
Did you? What
Maybe
the
you
heck?
just didn't get in there when you printed it.
I don't know. It's weird. Whatever. I guess I'll just pick this first.
Okay, if x can't be 1, what can x be?
2.
2. 0. What
It
else?
can be whatever they want it to be.
Anything else, just not 1. Yeah, negative
Negative
1,
1,000.
negative 2. It could be anything. So it could be anything
Not
over
just
here,
plugging in negative
anything
1,000.
over there. So that means you can plug in pretty much anything and it'll exist there, but it's not going to exist at 1. We still have to plug in 1 because what we're going to do is we're going to put a hole where it doesn't exist so that we know like exactly where it doesn't exist. So you're still going to plug in 1 even though the function doesn't exist there. So you plug in 1, you get 3 minus 1 is 2. But we're not going to graph a point there, we're going to graph a hole there. It's not included. Well, we kind of need it in order for our graph to like look nice. So 1, 2, this is where that top piece does not exist. It does exist everywhere else though. So to finish the line, my suggestion is to pick one value that's to the left of that point, so less than 1, and then one value that's to the right. So what's one x value that's to the left of 1?
0.
0. So plug in 0. This is going to be included because it's not 1. Anything that's not 1 is included. So when you plug in
Negative
0,
1.
you get negative 1.
So.
So that's right here. Okay. So that's 1 point. So it'll go this way. But it'll also go the other way because x can also be what? What else is this way? 2. X could also be 2 or 3 or 4 or 5. Let's plug in 2 and see what we get. Plug in 2, we get 6 minus 1, 5. So x can also be here, 2, 5. So that top piece, first piece of the piecewise function, it looks like a line with a hole in it. It's an entire line. It's just missing one value, and that value was 1, because it says x can be everything except 1. Now this one is different. This says the function can be 2, but only at the value 1. Now, when a line exists at only one point, it just looks like a point, right? Because it doesn't continue forever, it's just one single point. This one single point is the x value of 1 and the y value of 2. That's where the second piece exists. Now, coincidentally, it's right here on the hole. Now, if you're graphing with a pencil, you're probably not gonna see the difference, but basically, we have like, the first piece was a hole, but the second piece filled in the hole. This doesn't always happen. Sometimes the point is off the hole, so sometimes it's like here. And you'll have like a hole and then like a random point off the hole. But this time we basically just filled in our hole with our second piece, so that it's a nice continuous line. But usually it doesn't look like that. Alright, so those are different because they have the not equal to and the equal to part instead of the less than, greater than, etc. Okay. Alright, so